I'd like to thank Matthew's Friends and Helen and the other organizers for inviting me to tell you about our work. This is an interesting session. You've heard no standard of care, temozolomide, and now you're going to hear radiation. I have one comment, and that is that from the time I was a little kid, I knew that cancer therapy is poison, and the object of the game is to kill the tumor before you kill the patient. Okay? That's the way I'm not a clinician, I'm a scientist, but that's the way it's always been. And it's only somewhat recently that people are looking at things that are a little less poisonous and a little more targeted. The problem with some of that is the heterogeneity that Dr. Reynolds mentioned, which is if you look at 100 tumor cells from the same tumor in the same patient, you can see, if not 100, then certainly 20 different molecular bases of why these tumors are acting the way they are. Some of the cells will be resistant to all kinds of things. Some will be sensitive to all kinds of things. That is the nature of cancer. When we talk about different results in different models, that's frustrating to a scientist, but it makes total sense because you're going to get exactly the same data in different people. Different people are basically like different tumor models because the tumors aren't the same. So you have to take what everybody tells you and kind of keep that in mind when you're talking about some of this data. Okay. Thankfully, I do have a disclosure that actually some of the radiation work was supported by Nutricia, and they provide Ketocal for our experiments. Okay, so the potential clinical utility for this, I started out as a molecular biologist. Dr. Zhang Ro, who is my keto mentor and absolutely phenomenal. We worked on the same floor. We bumped into each other. He said, "Hey, you want to try this?" And I said, "Sure." And that totally changed the direction of my lab. Dr. Seyfried is the father of this whole thing, so he quoted Dr. Seyfried to me. And it was totally logical, okay? Tumors may not be able to use ketones as an energy source, so reduce the glucose. Normal cells can use ketones, keep the brain happy, keep the tumor unhappy. Very logical. I think in cartoons, because I can't remember all the biochemistry they talk about. Okay, so maybe that'll slow tumor growth, all right? Brain tumor patients often have seizures. Gee, this is used against seizures. Maybe that'll help. And the other thing is it's known to be somewhat neuroprotective. And radiation does damage normal brain, which is why they try to target radiation as carefully as possible. And frankly, if you know anybody with any cancer that has had multiple rounds of different kinds of chemo, there is something that they term sort of chemo brain, where people will actually be a little more confused and stuff. Well, this is neuroprotective. Maybe it'll actually help chemo brain. So I think this could be really cool. So we started playing with it. The thing is that when I went to start to play with it, the one comment I had was that nobody is going to use, not nobody, none of the clinicians I knew were going to use anything like this in a clinic unless it was in addition to the standard of care. It's not ethical for them to suggest not using the standard of care. They could get they can get sued. And also, frankly, you can talk about the therapies not working very well as much as you want. But when you talk about a group, it only helps 2% of the people. When you're talking about your mother, your father, your child, your loved one, your friends, you think you're going to be in that 2%. And when there's nothing else to offer, or nothing else proven that works to offer, people are going to want to go for every chance they can. They will try anything, which is why we're hoping they'll add this to the standard of care in the hopes that it makes the standard of care better. But honestly, I thought it would be pretty naive of me to think that patients would say, "No, I won't do standard of care and I'll give this a try because after all, you can cure a mouse." All right, so what we did is we took a standard mouse model. It is what's called syngeneic, means the cells come from the same strain as the mouse. The immune system is completely intact. That was important. We didn't realize how important. We now have a little data suggesting that the ketogenic diet actually helps the immune system against cancer. That's for another talk. We took the gene that comes from fireflies. We actually bought it. It's called luciferase. Added it to glioma cells, and now we've got a bioluminescent tumor model. The cells glow. We can take the mice. We can analyze their tumors, give them a little isoflurane gas. They go to sleep. You put them in a nice, warm, dark place, and they sleep through being scanned. Take them out, and they run around happy as a clam. I'm an animal lover. That's important to me. Okay, the computer actually gives you a picture. It false colorizes it, and it also gives you the number of photon counts. So you can very nicely track the growth of a tumor, so now we can actually see what's going on at various stages of the tumor. We could demonstrate, and this was just with an animal ketogenic diet, which was a 6-to-1. Animals on standard diet, the tumors grow that fast. Animals on ketogenic diet, they grow slower. This is awesome. But then we figured I wanted to be more clinically relevant. So that was when we approached Nutricia, And they said, okay, well, let's use Ketocal and see how that works. So we changed to Ketocal. It's 4-to-1. I know it can be used in people. I know 4-to-1 mimics what's used in people, so we went with that. So if you look at the beta-hydroxybutyrate, and we don't take it all the time because, again, you kind of have to take a little blood from the animal, and I don't really think we want to do that very often. But we did it early in the experiment, a little later in the experiment, and this is the diet alone. This is when we did the diet plus temozolomide. Sorry, this is radiation, and this is the diet plus temozolomide. And in all cases, the beta-hydroxybutyrate is higher, just as you expect. This is interesting. The glucose wasn't always different. So with the diet alone, we did see a drop in glucose, and that kind of lasted. But with the other therapies, radiation, there was a drop. But later on, the glucose didn't change. So I think, uh-oh, what's going to happen? Well, it turns out, in this model, it didn't make that much difference. So what that told us is, yes, the glucose dropping is probably important, but the ketones going up is also really important. And that also gets along with what Dr. Seyfried says about people freaking out about their glucose levels. Well, it's the glucose and the ketones. It's not just the glucose. So if the glucose isn't as low as you'd like it to be, that's not great. But if the ketones are high, okay, so you're still going to get some benefit. At least that's what it looked like to us. So we followed the animal weights, diet alone, no change in weight. This is kind of interesting, and I'll show you in a little bit why this is interesting. One of the animals, we do not do caloric restriction, by the way, because again, I thought, okay, I'm going to try and sell this to a bunch of clinicians, and they're terrified of their patients losing weight. Brain tumor patients don't usually have cachexia, but oncologists in general are very worried about that. And you're going to tell a patient, okay, we're going to take away all your comfort foods, and by the way, we're also going to drop how much you're going to be able to eat hugely. Didn't think it was going to work. But I've got an awesome dietitian that works with me, Leonora Renda, and she just titrates the food. So sometimes they actually end up being calorically restricted anyway, just to titrate their food to keep the ketones and glucose where they want to be. But we don't worry about telling them up front, oh yeah, we're going to have to drop you way down. So I figured that's how we're going to test it. This particular little mouse patient restricted itself. So she dropped her weight, but she was very happy. She was running around the cage, very healthy. Again, as an animal lover, we want them to be happy and healthy. When they're not happy and they show symptoms, we euthanize them. And she actually lived a really long time, whereas the rest that kind of maintained standard diet did end up succumbing sooner. I'll show you that in a minute. And then with temozolomide, this is kind of interesting. We had a transient drop in weight. The weight came back up. We haven't published this because, to be honest, as a scientist, I would have to take the standard diet animals and titrate their weight down and bring it back up, and that was a huge amount of effort that we haven't gotten around to yet. So what does the survival look like? Well, this is again a Kaplan-Meier plot. The faster the line drops, the worse the animals are doing. And you can see standard diet, median survival is somewhere between maybe 24, 26 days, depending on the experiment. Ketocal, they do quite a bit better. Temozolomide helps survival when it's used with standard diet. Ketocal, very much like what we just saw, extends life. But this really blew our minds. Okay. These are the animals that got radiation, and we give 2 doses of 4-gray. These are the animals that were on Ketocal that got radiation. And just in case you, like what I think our reviewers might have said, well, maybe you screwed up and the animals didn't have the tumors in the first place. Luckily, we've got bioluminescence. So here's an animal on radiation alone. And again, bioluminescence is quantitative, so that's the photon count. You can see that early on, the radiation kind of slows it, and then probably, I'm guessing the cells that were resistant to radiation just take off and go crazy. And here's the animals that were also given Ketocal. This is just one of the animals. Some of the animals took a little longer for the tumor to totally disappear. Some of them it was a little bit shorter. But basically, the tumor's there. It kind of is low. It tries to come back a little bit, but it's totally gone. So you do get some growth, and then it's gone. One of the things that I should mention is this line here. At about day 100, I decided that I was really tired of supporting these ladies to run around their cages and be happy, so we switched them back to standard diet. And we supported them for another 200 days, and the tumor never came back in any of them. And when we sacrificed the animals and looked in their brains, there was no tumor. So there was tumor, and it really was gone. So one of the mechanisms that radiation works through is to make reactive oxygen species. And in an early experiment we did in collaboration with Dr. Zhang Ro and his postdoc, Dr. Do-Young Kim, we demonstrated that about 3 weeks into the tumor, about a week before the animals were going to succumb, reactive oxygen species were very much reduced by the ketogenic diet. And this is something that's been found in epilepsy. And Zhang, being a major reactive oxygen species and that having to do with radiation, said, oh, great, let's look at this. When we saw that reactive oxygen species were down, but it potentiated radiation, we got really confused. I particularly got really confused. So I thought, you kind of have to hand wave and try to guess. So I thought, what if, when you give radiation, the reactive oxygen species pop up, it does its deed, and then it comes back down? And our previous experiment, because we could only look at one time point with the technology we had, only looked after it came back down. So we found a new way to look at reactive oxygen species, and that's a compound called 0102. It's chemiluminescent, so it actually makes a chemical reaction when there's reactive oxygen species. The same instrument that shows bioluminescence shows chemiluminescence, so you can actually get a readout of how much chemiluminescence there is. And you can see that reactive oxygen species are higher in standard diet than they are with a sham injection. Okay, that's good, it works. So then we did it in our tumor model. So looking at the 0102 chemiluminescence, at time 0, meaning just before radiation, the ketogenic diet drops the reactive oxygen species as expected, but it didn't spike. It stayed lower all the way across. There goes that hypothesis. So if anybody here has a brilliant idea as to why this is working with radiation and does totally not with reactive oxygen species, let me know. But we've got some other ideas that I'm going to show you about why maybe it's helping. The first thing that was happening about when we were doing this is we noticed that the bioluminescence signals we got from the animals on the ketogenic diet were bigger when the animals succumbed to the disease. Now that bioluminescence is ATP dependent. It only shows live tumor cells. So I think in cartoons, and I'm not a clinician. So I think what's making the animal and people succumb to the disease? It's overall tumor burden. What is the overall tumor burden? It's the tumor cells plus the edema that always accompanies these tumors, right? I mean, your brain, things can't get too big up there until you have a problem. So if the live tumor cells are going down or less when the animal has too much in its brain to survive, something else must be happening. So my guess was, well, what could you possibly reduce other than the tumor cells? The edema. So that was the hypothesis. So that's what we looked at. We have an MRI group. We have a little 7T MRI for animals, and they actually can interpret this for edema. It looks like a Rorschach test to me, but they can do it. And we took 2 groups of animals with the same size tumor, measured the edema, and sure enough, there is a substantial reduction in edema in these animals. Now, keep in mind, a lot of this had already been pioneered by Dr. Seyfried and his group in terms of inflammation and things like that, but that was always with caloric restriction, and this is completely without caloric restriction. One of the things that we had found early on in our work with the animal version of the ketogenic diet was that a bunch of genes had differential expression. And in fact, Dr. Rowe showed you one of the slides in his introductory talk showing that overall gene expression looked normalized. Well, one of the genes we found that was changed the most of anything was cyclooxygenase 2. Cyclooxygenase 2 modifies or mediates inflammation. And in fact, in addition to it going down at the RNA level, it goes down at the protein level. So the green fluorescence is cyclooxygenase 2. The blue are the nuclei, just showing that there's a lot of tumor cells. It's pretty easy to see that you've got a pretty substantial reduction in green. So the cyclooxygenase 2 is definitely down in the tumor tissue, not just in cells we grow or anything like that. Well, our fancy little machine also looks at fluorescence. I love that machine. And PerkinElmer came out with a molecule that will actually show you COX-2 in vivo. In other words, you can do this in the animal, and again, the animal's anesthetized, they come out, they run around, they're happy. So we could look at cyclooxygenase 2 in the animal. Yes, it definitely is increased in the brain tumor. We actually took the brain out of one of them and showed that it is completely located where the brain tumor is. And if you look at cyclooxygenase 2, in standard diet animals, it's fairly high. Keto-Cal brings it down. In animals that have been radiated, it goes up. That's exactly what you expect. Inflammation goes up after radiation. This is not uncommon. In fact, people are looking at some anti-COX-2 agents, or they didn't work very well, as an anti-tumor agent possibly. Well, ketogenic diet brings it right down. So again, another way that even after radiation, you're reducing inflammation. So maybe that's helping the radiation work better. The radiation kills a certain number of cells, but you're blocking the inflammation that goes along with radiation. Hypothesis. Hypoxia. As you can hear if you've listened to Dr. Dom D'Agostino give his talk, one of the things that they're trying is hyperbaric oxygen. Hyperbaric oxygen oxygenates the tumor, does a lot of things, but it's also being looked at to sensitize to radiation because hypoxic areas of tumors are resistant to radiation. If you can increase the oxygen, you can increase the sensitivity to radiation. So we also looked at hypoxia. And again, my cute little machine, can you look for a molecule they made called HypoxySense? This looks at carbonic anhydrase 9, which is an indicator of hypoxia. So if you look at, this is fluorescence. If you look at the standard diet tumor, there's more than in the ketogenic diet tumor. Again, it's quantitative. Here's the HypoxySense. Standard diet is high, keto-cal lower. Normal brain, these are just controls. Normal brain's a little lower, and if you don't inject, you get a little fluorescence, and this is just natural fluorescence that can be subtracted out. So there is a significant difference in the appearance of hypoxia in these tumors. Again, the tumor size was the same. Have we done this in animals that have been radiated? Not yet, because the tumors don't get big enough. So the next set of experiments we're doing is to actually implant the tumors, let them get to a pretty good size, and then do some of these things and see, okay, once the tumor is big enough that you can really analyze it, do we find these things if we give ketogenic diet and radiation after the tumor's gotten pretty good size? All right, just to demonstrate that it is quantitative, we did carbonic anhydrase. We just take out once the animal shows symptoms, we sacrifice the animal. For this experiment, we actually did it even a little bit before that. This is just 2 animals, so carbonic anhydrase and standard diet tumor. Keto-cal, it's definitely lower. Beta-actin is just a loading control. Another gene that is turned on, and a lot of these genes you've seen in the previous 2 talks that use different modalities, and caloric restriction, and then the Cancerna. Another gene that is turned on in hypoxia and is often on in some of these tumors is HIF-1 alpha. And that turns on a boatload of stuff, okay? It's also reduced. NF-kappa B, total NF-kappa B, no change. But NF-kappa B has to be activated. To be activated, it's phosphorylated. This is a gene Dr. Seyfried also told you about, definitely reduced. So essentially, unrestricted ketogenic diet is making a lot of gene changes, all of which have a lot to do with radiation resistance in one way or another. So to get the mechanism, one of the things that we've started to do is go back to an in vitro model. I understand that growing cells in a petri dish is not the same as having a tumor in a brain. I also understand that mice aren't the same as humans, most of them anyway. But to get at a mechanism, you really kind of need to be able to dissect things out. So our goal really is we've gone back to doing some in vitro work in the idea that what we find here, we're going to go back and test in the tumor cells. in the tumor tissue to see if we can actually dig out a mechanism and then find it in the tumor. So this is actually done by a high school student in my lab. I was hoping to have some other data that he sent me last night, but he needs to repeat it. But this is just showing that we can actually get, okay, this one. So this is the growth of the control cells. This is radiation, reduces their growth. Beta-hydroxybutyrate, put the 2 together, knocks them out. This is in media that is complete. It's got all the glucose these cells want. We did a previous experiment, in fact, the first experiment that got me involved in this, using cells that came from the 4th tumor of a patient. This patient had had every therapy known to give him back in the 80s. The tumor came back 4 times. My colleague grew cells from the 4th tumor. Those cells were so strong and made so many growth factors that we actually used media from those cells to help other cells. It made everything. When we added ketones to those cells, it slowed their growth. When we added ketones plus a chemotherapy agent that the patient had received, it wiped those cells. And that is in very high glucose media. So even with glucose, ketones alone do a huge amount. Drop the glucose, you're going to do even more. Okay, so the preclinical summary, because I'm really only showing you the preclinical work, is, and this is what I showed to try to get the clinicians to actually go for this, was, first of all, I think the ketogenic diet does have efficacy as an adjuvant therapy. There's no question. One of the issues with using something like this is the first thing you have to prove is it's not going to make the therapies that exist work worse. It doesn't affect that way. It makes them work better. Okay. We found we do have efficacy in the absence of caloric restriction. Would it work better with caloric restriction? That's quite possible. But again, to get it to the clinic, I didn't approach that. We see a reduction in the edema that's around the tumor. That's key. That'll help patients get off dexamethasone faster. We see a reduction in radiation-induced inflammation. And some of the things I couldn't show you is we do see a reduction in angiogenesis. What's really cool is that in Dr. Seyfried's work, they show a reduction of VEGF, which is a growth factor that helps promote angiogenesis. We don't see that, but we see a reduction in the receptor for VEGF. So essentially, you can kind of start to think about a 1-2 hit. Avastin, the therapy that isn't really exchanging life, but it is being used in a lot of patients, works against VEGF. So we're trying to convince the company to let us try their Avastin with the ketogenic diet to see, well, maybe a 1-2 hit on the growth factor and its receptor might work better. It'll remain to be seen whether they want to support that and whether that works. Possible value added is probable reduction in seizures. We haven't been able to look at that in our animal model yet. And we do have data that there's probably a reduction in growth factor signaling. Why is that important? Because there's a huge number of pharmaceuticals that are coming out to try to block growth factors and growth factor signaling. This stuff is so good that, honestly, when I first started working with it, I thought, this is snake oil. This can't be real. I mean, I didn't even believe my own data because nothing works on that many things in a good way. And this does. Okay, so does it have clinical utility? In my opinion, it's a resounding yes. From my work, from the work of others. Well, here's what happened. We published the radiation paper, and one person in particular and then a second person saw the paper, came to us, really wanted to do it. Went to the physicians. And I tried to get this approved as a clinical trial in our institution and was summarily shut down. She said she really wanted to do it. Her husband was absolutely gung-ho. He's got nutrition as part of his company. So the surgeon couldn't say no, so they did. It was a very large tumor. It had a 2-stage resection. It was in a very bad place to be taken out. Young woman, 39, I believe, Lee? 39? 37, sorry, 37. Young kids, young family, the nicest people. Friend of mine, in fact, I knew her before she had a brain tumor. And they went on this, and they stayed really good on the 4-to-1, and they worked with Lee Renda, our fabulous dietitian, checked ketones, checked glucose, all that stuff. And the tumor shrank a little bit, and then it stopped growing. And she's more than a year out, and it hasn't started to grow. And the surgeons went, whoa. And P.S., we now have a clinical trial. So the people who got it to work are, I think, the same people that are getting the ketogenic diet to keep going up and up in epilepsy. It's the patients. So the patients wanted it. The surgeons couldn't say no. There was a huge safety history because of the epilepsy literature. So they said, okay, go for it. And we've got data from a couple patients that look really good. So we've opened this clinical trial. So the clinical trial, and that's the NCI number. First of all, I'm a lab person. When I'm asked to talk to patients, I say, I'll tell you what happens in our mice. And I'm not going any further than that. But Lee Renda, our dietitian, fabulous. She had a poster here. Unfortunately, she couldn't stand at it because she was giving a webinar for the American Brain Tumor Association, which will be available for anybody to see, on ketogenic diet and brain tumors. So the brain tumor associations are sitting up and taking notice of all of our work, not just mine, obviously. Nerissa Honey, Dr. Nerissa Honey, she's a research clinical nurse, fabulous, with an expertise in caregiver quality of life and patient quality of life. Our neuro-oncologists who are on board, Dr. Lynn Ashby and Dr. Chris Dardis, who's very much on board now, I'm thrilled to say. It's ketogenic diet as an adjuvant therapy. We are not changing what they're doing at all, because if we tried, they wouldn't do it. So it's overall and progression-free survival. It's will they tolerate the diet. Quality of life, they're getting quality of life tests, not just the patient, but the caregivers. After all, they're the ones who are going to have to handle the diet. So quality of life issues, Karnofsky and other health-related quality of life we're keeping track of, like changes in seizure activity, changes in anti-seizure meds, changes in steroids. By the way, that first patient that did so well managed to maintain low glucose with dexamethasone. So it's doable. It's not easy, but it's doable. Neurocognitive tests, because brain tumors knock out neurocognition. Just the surgery can be a problem. Radiation can be a problem. So we have a question, okay, what does the neurocog look like? Is the ketogenic diet helping, or is it at least doing no harm? What's going on? Because there were a few things in the literature that suggest a drop in neurocog in animal models. We haven't seen it, in animals or in people. It's for high-grade gliomas, so mostly GBMs. We're looking at 20 gross total resection. That is, they take out anything that can be seen. The MRIs look clean. 20 subtotal resection. That means we can't get it all out. We can still see something, but we can watch to see if it grows. It is, again, plus the standard of care. We're doing the classic 4-to-1. Leah's helping them with this. And what we're doing is we're having them start the diet before they start radiation, continue the diet through radiation and temozolomide, and then if they want to drop back to modified Atkins after that for maintenance temozolomide, okay. And that way we're hoping we're going to help get compliance to be a little bit better. It's normal food. The patients can use Ketocal as a supplement if they want to, the liquid stuff. We're certainly not doing all Ketocal or all of anything else except natural food. Using the Keto Calculator online database. Lee is on the phone with these people, checking, constantly in contact with them, and everything gets modified as they need it. If they're too tired, if their ketones aren't high enough, whatever it takes to just constantly sort of titrate these people, exactly how I've heard so many other people talk about at this meeting. They're taking daily blood ketone and blood glucose levels. We also give them ketone urine strips, but they don't use that until later on, until they really pretty much have a handle on the ketone levels. We've been fortunate that the RSG-1 Foundation provides a keto kit, so we can give the patients a scale, a meter, and the strips. The ketone blood strips are hugely expensive, so at least we don't have to expect the patients to do that. The goals are to have the ketones greater than 3, higher is better, glucose about 70 if they're on dexamethasone and it can't go down that low, do the best we can. They're monitored for uric acid, cholesterol, triglycerides, LDH acidosis, and free carnitine. They're getting neurocognitive assessments. And then the one molecular test that we're doing, I'm a molecular biologist, I had to put something in. The one thing that is known to people can look at for whether or not a patient may or may not respond to temozolomide is what's called MGMT promoter. So patients that do or don't have that are going to have a different sort of life expectancy based on whether or not they're going to respond to the drug. So that's kind of it's going to end up being a stratifier, essentially, in our data, so that we can't say, oh, everybody did better, but they all had a favorable thing anyway. Favorable, by the way, you're talking a difference of months, okay? So favorable is a relative term. I don't do this. I sit in my office and try to find money, okay? So I've got 3 people that these guys started in my lab right out of college. Eric started in my lab right out of college after these guys moved on to other things. He is now a grad student in the lab going for his PhD, and I'm so proud of him. Alex Rossi and Raj Vatsa are 2 high school kids in my lab. Alex did the growth. Raj did the Western blot for the NF-kappa B. Kara Curley is a college student that was in my lab, did a bunch of the Western blots. I have a huge number of high school and college students. They keep me young and make me feel old at the same time. Collaborators, I couldn't do it without them. Phil Stafford is a statistician. These are our MRI guys. Mark Prula is head of neurosurgery research. And of course, my keto mentor. Everybody knows Zhang. He's amazing. Funding, again, I get funding from a bunch of high school students that raise money and these different places. And everybody else showed really pretty pictures of beautiful buildings they work in. I work in a really boring looking building. So this is pictures of where I play, and I'd be happy to take questions.